Good morning and hello everyone. Uh, Chapter 1 Introduction to Database Management. My name is Kurdo Jaza Mahmoud and I will be your instructor and your lecturer for this course. Now, anything you want, and if you want to get in touch with me, you can send me an email through kurdo.jaza@unique.edu.iq. Welcome. You see, databases are super important in today's world. Every organization, hospital, banks, universities, coffee shops, and even now markets, they require database. You see, learning this subject will seriously level up your computing skills. It requires time and effort, but it's worth it, hopefully, at the end. Think of it like this. Before you can build an app or a system, you would need to understand where and how data lives. So this class will explain these concepts. First, we will start with some review questions. Number one, differentiate between data and information and knowledges. Explain database characteristics. Explain DBMS features. What is ANSI Spark three-level architecture? What is concept behind data in independence? And explain database system environment. Now, no worries if you didn't know the answer to these questions, because in the course we will try to explain each part as easy as possible. Now, our outline would be database characteristics, a DBMS feature, development of a database technology, three schema architecture, and organizational impact of DB technology. Now, first, we will have some initial vocabulary. Hopefully, by now you are familiar with these terms. However, we will try to explain it more. Three key terms you must know. This is a must. Well, the first term would be data. It is a raw fact with no context, just numbers or words without any meaning. You know that this is a number or a word, however, you will not know what does it mean. What is the idea behind this number? Well, here comes the information part. With data, with the context, would be something meaningful, and this would be an information. Now, for the knowledge, would be information plus understanding, not just knowing the context. Also, you will understand that information and you will get insight for decision. Now, we have an example. You see, 14 alone is just a data, means nothing. If I told you 40, you will not understand anything. However, if I said 40 kilogram, now this is information. Now we know that this is the weight. 40 Celsius, different information entirely. 40 kilometer, yet another meaning. And you know that this is for a distance. Example of a data versus information versus knowledge. We have data, an example would be 95. What is this? It is just a number, meaning nothing. Information would be my score on the final exam is 95. Well, this is an information, it's a context. You know that not that 95 was the score of the final exam of a specific student, or yourself, or me. Now, the knowledge is that I passed with excellent mark. It means that I have information and meaning or interpretation. Why? Because 95 is a very good high mark. Now, with that mark, you will get excellent. That would be a knowledge. Data versus information. An example. You see in the left side, we have 331 Brillo dish soap 1.29, 833 BK Hill Coffee 4.99, and so on until reach the end CCC. Now, in the information part, in the right side, we will have sales region Northwest. We will have the store, which would be Superstore number 22, and someone bought item number 331. Description would be a Brillo dish soap units sold at 7156, and YTD sales would be 9,231.24. Now, also, this is an information. However, if you get a knowledge, the YTD sales would be of 1,231.24 is the best figure we had in the past 10 years. Now, this would be a knowledge. We have this pyramid. The first one would be data. Data are the raw facts unorganized and without any concept or meaning. Information would be contextualized data. By another meaning, data that has context. Knowledge means understand and interpret. Now you understand the information that you have and you interpret to something. Now here's come the question that I will leave for you. What is wisdom in this context? Database characteristics. A database is a collection of the persistent, shared, interrelated data. Well, you may ask, what is persistent? What is shared? What is interrelated data means? I will explain that. Persistent means that the data stays safe even after you close the program. Store on a stable storage like a hard disk or like a flash disk or anything that comes to your mind. Example, your student course stays in the university system even after you log out. Imagine if any time you log out, everything that you've done, everything that you upload will be gone. That would be a problem. Then that would be a database problem. Shared, the second one, the same database can be used by multiple users at the same time for different purpose. Another example would be at university, the registration office, finance department, academic staff, and all use the same student database, but different reasons and different roles. Interrelated data is stored as a separate piece, but they are connected to each other to give a complete picture. What do I mean by this? I mean, in a database, it is not an entire table that contain everything. No, actually, it would be different databases. One database, different tables. However, they are all connected together. For example, in here, we have a database or university database. We have the entities and the things stored would be student, faculty, courses, offering, enrollments, and so on. Now, the relationship would be the faculty teach offering. This is how relationship are, how they connect, how these entities are connect. Faculty teach offering. Students enroll in dash offering. Offering means this, of course, and so on. Well, we may have registration, we may have grade recording, course scheduling, and faculty assignment. Now, which one need to be a table? And we will explain it more in the upcoming sessions. Water utility database. We have entities, we have relationships, we have billing, payment processing, we have service start and stop, we have meter reading, and we have our entities, customers, meters, bills, payment, meter reading. Relationships would be bills sent to customer. Customers make payment and customers use meters. This would be the relationship between the entities. Database management system, DBMS. Now we move from a database itself to a software that manages the database. Now we know what a database is, and hopefully by now you understand what is the concept behind the database, why we need it, and so on. Now we will talk about the software that manages database. DBMS is a collection of a component that support data acquisition or collecting the data, data storage, data maintenance, updating or deleting, data retrieval, data dissemination or sharing and distribution, data formatting, presenting nicely. Well, storage and retrieval are the core or the initial function of a DBMS. If a DBMS cannot provide me with storage or a retrieval, that will not be called a DBMS or database management system software. Now, the type of database management system softwares would be Oracle and Access or MySQL, and they are categorized based on the enterprises. For example, if you are working in an enterprise and they ask you to create a database, your base choice would be Oracle or IBM DB2. And why? Because these databases will support large organizations. Now, desktop would be Microsoft Access, small for a personal use. Sometimes they will create to small businesses also a database using the Access. Now, open sources would be MySQL for the web application, and it is free to use. Now, embedded would be in PDAs and the smart cards. They will have a small database and built inside the devices. It is a very lightweight database. DBMS is a critical part of IT infrastructure. Almost every system you use daily has one behind it, if you know it or not. DBMS features: database definition, non-procedural access, application development, procedure language, interface, transaction processing, and database tuning. DBMS features would be the first one would be database definition. This feature is about defining the structure of your database before you use it, not a simple definition of a database. Now we know what is database. However, in DBMS, when we say we have a feature and it's called database definition, what do we mean? We mean defining the structure of your database before you use it. Think of it like designing a blueprint or a building before constructing it. What it get defined using SQL or graphical tools, you define tables, relationships, integrity constraint, and authorization rights. Well, what does tables means? Table mean where data is stored, row and columns. Relationships, how table connect to each other. We have different tables and how each one will be connect to uh, the other table. Integrity constraint, rules that define what data is allowed. Authorization rights would be rules that control who can access what, or we call it permissions. DBMS features database definition. Now we said table. What is table? Table is a 2D structure made of columns and rows. Now the student ID, student name, and GPA would be columns. What about the rows? Rows, also called record or tuples, and it would be one row per student. Now a student may have ID, student name, GPA, and so on. University database relationship window using Microsoft Access. You see we have student, we have enrollment, and we have courses offering faculty and faculty-1. Now you see we have a relationship between student and enrollment, and it would be to one to many. One student can have many enrollments, and the student and enrollment courses and offering, these are the tables. The relationship between them are assigned as one to many, one to one, and many to one. Now, university database ERD using Visio Professional. Okay, the previous one was from Access. Now this one is from using a Visio Professional. It's a software that you can use it. Now we have a student offering faculty enrollment and courses. And as you can see, student can register to enrollment and offering accept enrollment, and teachers offering teachers, faculty, and courses have offering. Of course, faculties will have supervisors. Now, DBMS features non-procedural access. Most important DBMS feature is to answer queries. or I ask you a question about the data, that DBMS should give me that answer. Query would be a request for a data to answer a question. Indicate what part of a database to retrieve, not the how part. Okay. I don't need to know how the data will be retrieved for me. I just want my specific data. How will it request it and how will it retrieve? That would not be my problem, neither the problem of the user. Improve productivity and improve accessibility. Example, SQL select statement or graphical tools like Microsoft Access Query Design window. Graphical tool for non-procedural access. Well, this would be a graphical tool for getting something that you want. DBMS features application development. We will have a form, we will have a report. Form would be a formatted document for data entry and display. And by now you should know what is form is. It is something or formatted document that you will use it in order to entry a data or display a data. A report would be a formatted document for display. Use non-procedural access to specify data requirement of forms and reports. And a very simple example for this would be user open form or a report, and then DBMS run SQL query, data is fetched from the database and display nicely in a form or a report. This would be a simple procedure that happens behind when you open a form or a report. Now, sample data entry, you will have your specific places to enter data, and you will have the table that would be recorded inside it. Now, we have a sample report. This would be a type of report. We said that we will have a form in here. We said that we will have a form and we will have a report. This is a sample for a form or a data entry form, and this is a sample for a report. What do we mean by a report? Now we have a dashboard of Oracle Apex, which we will be used for this course, and hopefully you have some information about it. Otherwise, we will provide you with the links in order to get familiar with. Now, this is form in Oracle Apex. We have a customer, name, contact type, title, company, email, phone, and cell phone and fax. This is the report in Oracle Apex. It gives you an information about your data. And we will have DBMS features. Another DBMS feature would be procedural language interface. SQL is powerful, but it has its limits. Sometimes you may need to do more complex things, like repeating a task automatically, making a decision. If this happens, do this or do that. Processing a large amount of data in one go, not doing like 2 to 3 selects and then you combine all of them. Well, this is where procedural language interface comes in. This would be a job of a procedural language interface. If I asked you in an exam if I wanted to repeat a task automatically or making a decision or processing a large amount of data, I will be using dash. That dash would be procedural language interfaces. Well, it's a method that combines a regular programming language with a SQL to get the best of both worlds. And of course, we have an example for this, so you can search for it. Oracle has PL or SQL. PL would be stand for procedural language, and SQL, we know that it is structured query language. And of course, Microsoft has Transact SQL. And why we need this? Because sometimes we may need a batch processing, or we may need customization and automation, not doing everything by hand, or we make a performance improvement. DBMS features transaction processing. Transaction is a unit of work that should be reliably processed without interference from other users and without loss of data due to failure. Example, withdrawing a cash at the ATM or making an airline reservation or cause registration, process large volume of repetitive works, and control simultaneous user. Well, let's have an example. Recover from a failure. Example, what if we have an ATM machine? Let's say we will insert a card and then we will request an amount. Then step three comes in, the system deduct the requested amount from my account. Then the ATM should dispense the cash or give me the money. Now, what will happen if the power cuts between step three and four? You inserted the car and you requested the amount. However, well, the system now has no power and the fund being deducted and step four dispense the cash is not happening. Well, that would be a problem. And this transaction processing will help this, will reverse the whole thing and roll back as if never happened. Your money stays the safe. If the power goes off in step three, nothing happened, no problem with your money, which should happen because of transaction processing. We have database tuning. What is database tuning is monitoring and improving the performance of a database over time. Utility program can be provided to do what? Reorganize the database. Over time, data gets fragmented and disorganized. Select a physical structure for a better performance, with choosing the best way to store and index data. Repair damaged parts of a database. Tuning tools can detect and repair these issues. So we have a tuning tools that will do these work for us. Very important DBMS that support large database with a simultaneous user. Well, why simultaneous users? You see, because in a small personal database, performance is rarely as an issue. Well, it's a very small and you don't have many data and not many transactions. Performance will not be an issue. However, in a medium business database, medium and occasional tuning will be needed. In a large enterprise databases, banks, telecom, universities, this would be very high. The importance of tuning and constant monitoring is required to make sure that your data will not be uh, damaged. Database technology evolution, it started from the era of 1960s, 1970s, 1980s, and 1940s. We will have generation 1, 2, 3, 4, and the orientation. 1960s was the first generation, and it was a file, the major feature of file structure and proprietary program interface. Then in the second generation, it was network navigation, network and hierarchies of related record standard program interfaces. Then the third generation came, and it was the relational non-procedural language optimization transaction processing. Then the generation 4, which is object multimedia active distributed processing, XML enabled. DBMS marketplace, the enterprise DBMS would be Oracle SQL Server, DB2. These are very strong for the enterprises. Oracle dominance in Unix, strong in Windows. SQL Server is a strong, very strong in Windows. DB2 Store strong in mainframe environments. Significant open source DBMs would be MySQL, Firebird, and PostgreSQL. And PostgreSQL is very good for the a large amount of data. Now, desktop DBMS would be Access, which is a dominance, the Windows, as we know, Fox Pro, Paradox, and Approach FileMaker Pro. Now, data independence. This was the one of the question of one of the semesters. What is data independence and so on. So software maintenance is a large part of information system budget, and it is 50% goes to database changes. Data independence is a concept where DB should have an identity separate from the application. Computer application, we mean computer program, report forms, then use it. The separate identity allow DB definition to be changed without affecting related applications. Three schema architecture. In mid 1970s, the concept of data independence led to a proposal of a three schema architecture. Schema means DB description. Now, three level of DB descriptions or DB schema. We have external view, conceptual view, and internal view. Well, for ANSI Spark 3 schema architecture, we have, as we said, external and conceptual and internal levels. And in the external level, we will have a view 1, 2, or n. The conceptual level, we will have a conceptual schema. And for the internal level, we will have internal schema. Now, three schema architecture, external level, conceptual level, internal level, as we explained it in here. Now, let's see what each one means. Now, for the external level, it is the user level. Each group of user can have separate external view or view for short of a database tailored to the group with specific needs. Conceptual level would be representing the entire database and define the entities and relationships between the tables and entities. Internal level represent the entire database and the storage view of the database, and it defines file collection of data and storage device such as the hard disk. This would be the internal level. Objectives of a three-level architecture, why we use this. First, all users should be able to access same data, or a user view is immune to the change made in others view. If, for example, if I opened my account and I did some changes with my application, this would be only for me, not for the other users. A user should not need to know physical database storage details. Well, this is not the job of the user. Now, objective of three-level architecture again, continued. DBA should be able to change database storage structure without affecting the user's view. DBA means database administrator. Internal structure of a database should be unaffected by change to physical aspect of the storage. The database administrator DBA should be able to change conceptual structure of a database without affecting all users. For example, I have a problem with one of my table. I will change something inside it. However, for the user, it is the same. They will have the same experience. ANSI Spark 3 level architecture, again, as another uh, illustration, we have external, as we said, the user's view. The conceptual level would be the conceptual schema or the entities and their relationship, and the internal level as discussed. Then a physical data organization, which would be the database. Now, ANSI Spark 3 level architecture. External level, user's view of a database describe a part of a database that relevant to the particular user. Conceptual level would be the community view of the database, and what will it describe? Describe what data is stored in the database and relationships among the data. Now, internal level would be the physical representation of a database on the computer and describe how the data is stored in the database. Different between the three level of ANSI Spark architecture. We have external view, 1 and 2. We have a conceptual level, and we have the internal level. Now, for the external view, 1, for example, would be student number or SNO, an F name, which would be first name, an L name, last name, age, and salary. We will have another external view, which would be staff number and last name and branch number and so on. Now the conceptual view would be staff number, first name, last name, DOB, salary, branch number, and so on. For the internal level would be struct staff, int staff number, and so on. This is the program that has been written using the C++ or C. Data independence again. The logical data independence refer to immunity of external schema to change in a conceptual schema. For example, uh, if a conceptual schema changes, the External schema should not be changed. Conceptual schema change, addition, removal of an entity should not require change to external schema or rewrite the application program. Physical data independence refer to the immunity of a conceptual schema to change in the internal schema. Now, internal schema changes, for example, using a different file organization, storage structure, or devices, this should not require change to conceptual or external schema. Physical data independence refer to immunity of the conceptual schema to change in the internal schema. Internal schema change, for example, using a different file organization, storage structure, and devices, again, should not be required to change the conceptual or external schema. Data independence and CSpark three-level architecture, external and schema. External schema. This would be the external conceptual mapping. External would be mapped to the conceptual schema, and the conceptual would be mapped to the internal schema. Schema mapping. It describes how a schema at a higher level is derived from a schema at the lower level. External to a conceptual mapping provide the knowledge to convert the request using an external view into a request using the table in the conceptual schema. Conceptual and internal mapping would be provide how entities are stored in a file or in the files. Distributed processing. Distributed process became a crucial function for DBMS due to the network computing and the internet. It allowed geographically uh, dispersed computers to cooperate when providing a data access. Example, e-commerce. Many DBMS support distributed processing using the client-server architecture. Now, what is the client-server architecture? Client-server architecture is an arrangement of a component, client and server, and data among computers connected by a network. It provides a flexible way for DBMS to interact with the computer networks. Now you see in the A, we have client, server, and database on the same computer. Client, server, and the database. In the B, we have a multiple client and one server on a different computer. Client number 1, 2 to 3, or to the N. Then we have a server. That server has the database. Now the C would be multiple servers and databases on a different computers. We have clients 1 and 2, and we have server 1 and 2 and 3, for example. And then we have each server will have its own server clients. So multiple servers and database on the different computers. Organizational roles, specialization, functional user, information system. This specialization would be either functional user or information systems. Now for the functional user, the indirect parametric power for the information system would be DBA, analyst program and management. And the DBA, of course, database administrator, would be technical or non-technical. Now we will talk about each one. Organizational roles. Functional users, or as we explained it in the left side, which have indirect parametric and power. These functional users interact passively or actively with the database as a part of their work. For example, indirect users play passive role where they are given a report or the data extracted from a DB. For example, a manager. You will give him a report. He will be indirect functional user. Well, we have a parametric users would be users are more active than indirect users. Request form report using parameters input value that changes from the users to usage. Example, the department name. Now, the power users are users most active, uh, which can build form or report when needed. Now, organizational role for information system professionals. Interact with the database as a part of a developing an information system. We, we will have DBA, analyst programmer, or management. The DBA database management database administrators would be assess both information system and professional and functional users. Analyst programmer is responsible for collecting requirement, designing application, and implementing information system. And of course, management has the oversight role in DB and information system development. Database administrator, DBA, more technical and DBMS specific skills, and data administrator, less technical planning role, or data administrator and database administrator. This would be the difference between these two. We have figure 1.9, the database system environment. As you see, we have procedures and standards. We have application program. We have DBMS utilities, DBMS data. We have hardware, computers, and we have a lot of end users and so on. Now you see from the top right, we have a system administrator supervise the database administrator, and the database administrator manages the computer or the system. Now, also database administrator would write and enforce the procedure and standards. Procedure and standards will be used in the application program, and end user will be the person that use application programs which they want to access DBMS. Of course, programmers will write the application and program, and database designer will design the database for us. And of course, hardware will contain the DBMS utilities. As a summary, database and database technologies are vital to the modern organization. Without database, you cannot work anymore in any place of the world. Database technologies support daily operation and decision making. Non-procedural access is crucial feature, many opportunities to work with the database. Now, this would be a word of review question that we asked in the first part. Difference between data, information, and knowledge, which we explained it. Then the characteristics of a database. Explain DBMS features. What is ANSI Spark 3-level architecture? What is the concept behind the data in independence? And then explain the database system. We have a review question 2, which is the final exam of April 2010, question 1. The first question was outline three schema architecture distinguish clearly between the levels. How does this architecture helps to ensure the data independence? Now the second question was for each following change, identify which, if any, of schemas in the three schema architecture will be need to be changed. Explain briefly. A large mailing list need to be stored in two smaller relation for performance reasons. An application need to access an existing personal attribute which it did not need before. A personal record is to be added to the database. Now, I will leave these questions for you as I explained it. Similar examples in this video. This is the end of the video, and I hope you understand it well. In case you have any question, you may ask me through the email. Thank you very much.